So a quick background on cloud computing. Historically, what we've done when we've had services that we would like to run externally, we would either host our own services and pay for network access, or we would outsource to an IT service provider to, for example, a data center. There are challenges with this. First of all, it's expensive, having our own machines and maintaining them, and it's not elastic. We can't really add a new machine because we have a high demand today. We have to plan for a high demand. Which also means that the entry barriers are quite high. You have to actually purchase the machines, you have to get the network up and running before you can actually start delivering your service. With cloud computing, we instead buy our IT services by third party. They're available when we need them, typically in the same time it takes to boot up a machine. Therefore we can scale quickly, we can add a new machine when we want to. There is no expenditure to actually get started. You can start immediately and only pay for the machine that you have up and running then and there. And so it's easily accessible, and we don't have to worry about networks and stuff because that is already taken care of by the cloud provider. There are 5 main principles to cloud computing. First of all is that we pool our computing resources with others. We share the same underlying hardware, and we do this through virtualized computing. So we have our own virtual machines. So we think we run our own machines, but they are in fact virtual and they run on shared hardware. This enables us to scale up and down as we need. We can add a new virtual machine relatively easy. And this is automated, so we can easily add new machines. We don't have to go in and do a lot of manual work to get up a new machine or remove an old one. We only pay for what we actually use at the moment, so we can easily experiment with adding a machine and removing them, and we don't have to pay for the excess capacity when they're not running. Most of these, as you notice, are geared towards the underlying technology, and they enable a cloud provider to offer services at lower cost than if we have to have the machines by ourselves. This in turn means that we can get away with paying for only when we're using the machines, because when we're not using the machines, someone else is. There are other things here as well, which we don't have to worry about, or we have to worry about in some sense, but to a lesser degree, which is the network. What type of network does the network connection does the cloud provider give you access to? How do we access the machines or the services? Is it via a web interface? Is there a programmable API to get access to them? And how do the cloud provider deal with storage and databases and such things? What's the level of service they actually provide us with? The benefits of going to the cloud solution is that it's a lower initial barrier. We don't have to pay for the machines up front, so we shift from capital expenses to operational expenses. We only pay when we're actually using the machines. We don't have to wait for new service, we don't have to order them, we don't have to go through all the formalia of getting them in place and installing them and cooling them and connecting them, etc., etc. They are connected and they are ready to be used immediately, so we are more responsive with a cloud solution. And security, well, in some sense, we have people who are employed to only take care of security at the cloud provider's facility. But in some sense, depending on what type of cloud service we use, we have to worry about the security ourselves. So for example, if we buy an infrastructure as a service, well, physical security, no one gets access to the machines. Well, that is probably taken care of, but we still have to take care of the security of our own machine so that one doesn't get hacked. Different cloud services range from anything between infrastructure as a service, where you basically get your own virtual machine and you have to install the operating system from scratch, up to software or applications running as a service, where you are just a user to a service that's provided by someone else. We could also add data center as a service if we want to add our own private clouds, for example. Some examples of this is not an exhaustive list in any way. Amazon has basically any type of platform or any type of service that you'd like to have. DigitalOcean, same thing. Microsoft Azure. Google has a range going from infrastructure as a service up to platform or applications as services. Some reasons for going to the cloud is that we need more capacity, we need more computing power perhaps, we need more storage capacity, we may need it for a specific point in time, or continuously that we need recurringly every night, for example, and we need to have more capacity than what we have locally, so we rent that from a cloud provider perhaps, or we have a specific event that we want to take care of in some way. We don't want to specialize in server maintenance. We don't want to have people on call to replace hardware in the middle of the night or run upgrades to the operating system or anything like that. We want to have higher reliability and availability than we can, as a single company, provide. That includes power outage, network outage, and server machines themselves. We have or may have a need for immediate scalability so that we can immediately, or rather quickly at least, add more capacity or remove capacity when we don't use it. And some books also say that the software licensing should get easier. I wonder, but some books say that. And challenges when developing a cloud application is that, first of all, understand what need do you have, what service level do you have. For example, how many servers, how should the service be configured, for how long, how often, what type of memory do you need, and so on. This is sort of connected to your quality requirements, your performance requirements, your availability requirements, your reliability requirements, and so on. These are reasons for why you're going to the cloud in the first place. And remember, it's probably not just one quality requirement that is important. It's always a blend of requirements. Cost is one of them, and performance is another one, for example, and you need to balance both of them. Once you've decided that you want to go to the cloud, of course you need to rethink your software architecture such that you can actually utilize your scalable platform in your software solution. In order to be able to scale quickly, adding new machines, adding new machines on the fly, you want to automate deployment of your application so that you spin up a new machine, you deploy your software, and are up and running with more capacity as quickly as possible and without any human intervention. If you go to the cloud, you will need to have different test environments, staging environments, and which are different from your deployment environments, so that you don't get tempted to go in and test your current bug fixes, for example, in the deployment environment directly. And this is a challenge to get these to be as equivalent as possible to your deployment environment, so that you, when you run your tests, when you develop your solution, you are likely to run into the same problems that you have or are going to have on your actual deployment servers. Automated deployment of your application was one. Automated provisioning and orchestration, making sure that your software stack is installed before you deploy your application. So if you're using Ruby, for example, or Ruby on Rails, then that you have the right version of Ruby on Rails, that you have the right version of Ruby, that you have the right version of all the frameworks that go into your application before you actually deploy your application. Making sure that you have the right database, and making sure that this database is able to scale as you need it to scale when you go to the cloud. For many users, you'll be fine with a standard relational database. They are easily scalable over the several machines, but there are alternatives today with the NoSQL databases, for example. Security. This is one of the most important things that you need to address when going to the cloud. So, for example, if you go for an infrastructure as a service or a platform as a service solution, you need to take care of security yourself. You need to harden your operating system, apply the latest patches, etc., etc. Depending on how the cloud provider is organized, and depending on how storage facilities, databases, and block storages are offered, you may need to protect your application from other applications, from other users of the same cloud provider. And when you have data in the cloud, make sure that it is protected, encrypted in some way. There are multiple instances where storing things in plain text means that it is accessible by others, either by accident or by intention. Making sure that your licenses are cloud friendly, making sure that you're keeping on top of all the legal standards, regulatory standards that are relevant for your application. Are you even allowed to have this type of data on the cloud, and in what way do you need to store it then? Maybe you need to encrypt it in some way, legally. So in summary, there are many reasons for going to the cloud, and there's a service level which should be just right for you. Different levels are offered, many different levels. But when you do go to the cloud, there are a unique set of development and management challenges. So in terms of development, you need to think about how you make use of the cloud in the best way. And for management, there's a different set of challenges that you need to worry about when you go to the cloud.